Hello, thank you for watching my presentation on using BERT for sentiment analysis on SEC Securities and Exchange Commission data. This is an overview of what we are going to cover. Transformers, BERT, Roberta. We'll talk about the data sets we used to do some sentiment analysis, our methodology, the results, and conclusions. So in this project, we use BERT to do sentiment analysis on some natural language data from the Securities and Exchange Commission. And we also give back the code that we wrote to do this. It's publicly available. And I'll just do a little sidebar on these programs we wrote to do this project. So you have example.py that does the sentiment analysis, and we have a dataset gen.py that pulls the data from the SEC. So we hope that in the future we can use these to do even more sentiment analysis on SEC data. All right, so first of all, let's talk about Roberta. That's the classifier that we use for this project. So it is based on the transformer architecture, and Roberta is also based on BERT. It's a refinement of BERT. BERT is based on the transformer, so that's the lineage. So to understand Roberta, we have to understand what transformers are. So transformers are, you can think of it like another layer in a neural network, like a convolution layer. It doesn't work anything like a convolutional layer, but nevertheless, we can think of it like another layer in a network. And at the end of the day, transformers use this attention operation, and the attention operation is a vector operation, and I've given the formula for it here. So just to keep in mind, transformers are fit like other machine learning algorithms and then applied to some task, and so they're fine-tuned. This is the transformer architecture, and one thing to take away is that BERT is only using the left-hand side of this diagram here. So BERT only uses the input encoder part of a transformer and relies heavily on this multi-head attention operation. And you can see that transformers themselves have feed-forward neural networks in them. That's another component. So very important in the transformer architecture, we have this scale dot product attention operation, and this is just a schematic of how it works. We copied it from the paper on transformers. And then what the transformer architecture does is it packs vectors into matrices and does lots of these scale dot product attention operations in parallel. And that is for performance reasons, because if we can do things in parallel, we can get them done faster. And so the way that we parallelize that scaled dot product attention operation is we pack our input vectors into matrices and take advantage of operations that hardware like graphics processing units or tensor processing units can do to speed up our computation. So the attention operation, it has three inputs: a query, a key, and a vector. And these are not queries like search queries. All three of these come from one input token to the transformer. So that's just something to keep in mind. And then the attention part has to do with how we pack multiple inputs into one matrix, and then they all get a chance to influence each other through the attention and the feed-forward neural network. So and that was a very fast overview of the transformer architecture. This is just some equations copied out from the original paper to give you a feel for how the multi-head attention operation really works. And just to keep in mind, there's lots of terminology like attention, queries, keys, and values. This all really boils down to matrix operations that we do on tokens that come from some input text. And so we will post a link in the YouTube video we're creating here to these slides so that anybody who's interested can go and dive a little deeper into these resources here we find are the best. And just interestingly, Christopher Manning, he has a lecture on YouTube from a class he gave at Stanford where the author of the Transformers paper shows up for the class and lectures on Transformers. So that's a pretty good indication that this Transformers architecture is important right now in the information retrieval world. Okay, so now we talk about BERT. So BERT is based on Transformers, and we took a look at the original paper for BERT, and there you can see that BERT is only using the left-hand side, the encoder part of the transformer architecture. So it's a little bit simpler than a transformer. And the way that the authors suggest one uses BERT is first to pre-train it on 2 tasks. And from what we can tell, these tasks are simultaneous. We took a look at the source code. So there's a next sentence prediction task and a masking task. So these 2 tasks, the first one is we give BERT 2 sequences and we ask it if the first sequence follows, the second sequence follows the first sequence in a document or not, or if they're just randomly thrown together. That's one task. And then the second task is this masked token prediction task, language modeling task. So we take some text, we would just remove some tokens from it, and we ask BERT to guess what the values of the tokens are. So we fit BERT first on that, doing some pre-training, and then we fine-tune it on a downstream task. And in our case, the downstream task is going to be sentiment analysis. So the authors give some directions if we want to do text classification, what the inputs ought to look like, and how to interpret the output for text classification. So they want us to use just a text and an empty set for the inputs, and then look at the output for this CLS token. The CLS token is something that BERT injects onto the beginning of every text sequence that it gets. I didn't find in the paper a lot of discussion on how the CLS token came into existence, but just that for practical reasons, it's useful in downstream tasks for BERT. Okay, so now we've talked about transformers and we've talked about BERT, and this brings us to Roberta, which is the actual text classifier that we used, or language representation algorithm that we used for our little experiment here. And Roberta is based on BERT, and it is really just a tweaking of some of the parameters that BERT is used in the pre-training process. The architecture is the same. So, okay, transformers and BERT, they came out of research that people did working for Google, and Roberta came from Facebook. So, like I said, Roberta is based on BERT, and the creators of Roberta just did things a little bit differently to pre-train it. Interestingly, they do away with the next sentence prediction part of the pre-training. They found out that they didn't get any better results using that. They do this dynamic token masking instead of a static token masking. So in that choosing tokens to predict, they found it worked a little bit better if they just do that on the fly as we are doing the pre-training task for Roberta. They increase the batch size, and they use this byte pair encoding. And the byte pair encoding is not done for any performance reasons, but the authors, they use it because it's more compatible with text data that's out there in the world. Okay, so of course the authors, creators of Roberta, report that they get better performance when they use their configuration than with the original BERT setup. So now we're going to talk about the data that we use for these experiments. So there's a Yelp data set that we found from a guide on how to use Roberta. And then there's the SEC data set that we created ourselves. So just to give you an idea what the Yelp data looks like, the inputs, one does not need to do any pre-processing tokenization or word count vectorization, anything like that. It can just work on the text directly. So this is an example of an actual input that we used when fitting Roberta to the Yelp data. Okay, and then the other thing is the labels are just the values 1 and 2, and 1 indicates positive sentiment and 2 indicates, 1 is negative and 2 is positive. So second data set is the Edgar data set that we created, and we just made it to be in the same format as the Yelp data, but we use for positive sentiment if the share price went down, the percent change in share price is down at the end of the quarter after the quarterly report came out, and positive otherwise. So just to talk about that a little bit, there's the Edgar database that the SEC makes available. Public companies have to publish different reports to the Edgar database, and one of those is the quarterly report where they report profits, losses, and so on and so forth. And then we marry that that quarterly report to TD Ameritrade has a free REST API that we can use to download historical price data. So we can get the quarterly report for some quarter for a company, and then we can get the stock price change from TD Ameritrade, and we can match those together, and we can get a notion of if the quarterly report was good. If the stock price went up by the end of the quarter, we say that's a positive sentiment, and if it goes down, we say that's a negative sentiment. So like I said, all this source code is here in this GitHub repository, and we'll give a link to that on YouTube. Okay, so there's an example. We found it on medium.com, and we did not know that Medium charges $5 after so many times when you look at a paper on it that's hosted there. So by the time we found that out, they had us over a barrel because we needed to get the project done, so we paid the $5. But everybody should be aware of that. Now, this guide that we found, it introduces the Simple Transformers Python library, and Roberta is one of the things that's available in that library, and it makes it very easy to use Roberta. It's really just comes down to 3 lines after you put your data in a data frame for training and evaluation. You just instantiate the classifier, train the model, and evaluate. Okay, so one little, just an aside, a tip. Yeah, Simple Transformers uses PyTorch, and there's Docker images out there already set up with PyTorch and GPU support, so you can just go ahead and fire up that Docker instance, and then that's the quickest way, I think, to start using the Simple Transformers Python library. So we follow the example from medium.com, and we ran that on the Yelp data, and then we also use the same example on our SEC data, and we get some results. So just there's some limitations. Not every ID that's there in the quarterly reports, you can map that to a ticker to get the price data for it, and then all of the ticker symbols are not necessarily reported in the TD Ameritrade REST API that we use to get the price data. So you just have to keep those 2 things in mind. So for the results, we ran the program on both data sets, and we got the Matthews correlation coefficient and just the confusion matrix classification outcomes. Okay, so here's the results, and what you can take away from this is I don't need to quit my day job because we did not do a very good job, I think, of doing sentiment analysis on these quarterly reports. We can see that just on the baseline example, the Yelp data, Roberta does a fairly good job. The max value for the Matthews correlation coefficient is a 1, and Roberta gets 0.88 on that. So I think not too terrible of results there. And you can just see relative. The true negatives and true positives are about an order of magnitude greater than the false positives and the false negatives. However, on the SEC data, we see that Roberta does not do very well. It's just really classifying everything in the negative class, and I think that's because of the way that we were preparing the data, and we just ran out of time to work on better ways to do that for this presentation. So finally, our conclusions here. We think that the example shows Roberta is quite capable of doing sentiment analysis. However, the data that we give it, the SEC data, we think it's not prepared properly. It's not a class imbalance problem because the classes are about evenly balanced. We think that, number one, we're not giving Roberta enough data. So that's another thing. It takes time to download all these quarterly reports, and then on top of that, it takes more time to play around with how exactly we want to parse that data and feed it into Roberta. So these are some opportunities for future research. We think that using a better parser is one thing, and then also probably parsing these quarterly reports into smaller segments before we give them to Roberta will give us some gains in performance. So what we want everyone to take away from this presentation is that we have now a GitHub repository. We have some Python code that can pull data from the Securities and Exchange Commission. It can pull natural language data. And then we have a way to get a sentiment because we can see what the market thought of that quarterly report by looking at the historical data. So that's the end of this presentation. Here are the references. We'll post, like I said, a link to this presentation on YouTube so that everybody can get a hold of it. And that is all. Thank you for attending, and have a great day.